1.6 is about equations and inequalities that involve the absolute value function. So let me give you the definition. Most people know what absolute values are in a very practical sense. Like most people can tell me the absolute value of 5 is 5 and the absolute value of negative 7 is positive 7. But if you want to describe arithmetically what absolute value does, this is the simplest way to do it. What absolute value of x equals is x if x is bigger than or equal to 0. But it's negative 1 times x if x is less than 0. Right? I mean, the reason why absolute value of x is, absolute value of negative 7 is positive 7 is that it multiplied negative 7 times negative 1 to make it positive. I mean, you could say absolute value of x is the same thing as the square root of x squared. That's another algebraic formula for what absolute value does, but that seems extremely complicated compared to how simple absolute value actually is. What it does arithmetically to x, it either leaves x alone or it multiplies x by negative 1, depending on whether x is positive or negative. Absolute value of x, this is a handy way to think of it, it's the distance from the number x to the number 0 on the number line. Let's draw the number line like that. And some handy rules about absolute value are that it's good to know that the absolute value of a times b is the absolute value of a times the absolute value of b. But I should warn you, the absolute value of a plus or minus b does not equal the absolute value of a plus or minus the absolute value of b. Well, I mean, there are some numbers for which something like this would be true, but it's not, there is no rule like this second one that will be true for all real numbers a and b. This makes working with absolute values difficult when you're solving equations and inequalities. Usually what you have to do when there's absolute values involved in a problem is you have to go to some work at some point to remove the absolute values, to rewrite the problem in an equivalent form without absolute values. And to do that there are a couple of rules. It depends on whether I'm working with an equation or an inequality which rule to go, but it goes like this. If b is positive, then anything that looks like absolute a equals b, well, absolute a equals b can be rewritten in this equivalent form. A has to equal plus or minus b. And if b is bigger than or equal to 0, then absolute a less than b can be written in this equivalent form. Negative b less than a less than positive b. And the inequality absolute a bigger than b is the same thing as saying that a is less than negative b or a is greater than positive b. And of course, if any one of these was, if I had a less than or equal to there, then I would put less than or equal to there, etc. And similarly for the other rule. This is one of these rules that, in fact, even this first one, it's one of these rules that I don't really have memorized so much as understand. I mean, the more you memorize in math and the less you understand, the easier it is to get something kind of screwed up when it comes time to use it on a test. Some things are easy to memorize. Apparently, this is difficult to memorize because when I give a problem like this on a test, I routinely see people mess up the application of this rule. So even though it looks simple, I guess it's because the second line and the first line look so similar that it's just easy to get it wrong. So I do these problems without memorizing the rule, and I'll show you what I mean just sort of by thinking about it. I try to work my way through them. So let's try an equation. You know, absolute values are deceiving because they look like parentheses, but I can't just subtract 3 from both sides and make this go away. So I have to rewrite this problem without absolute value so I can then do algebra with it. I mean, there's a limited amount of algebra I can do on this equation without having to get rid of the absolute values. So what I want to do is to use that first rule for equations, I stop and think about it, and I forget about how complicated that thing inside there is. This says that there's some number here whose absolute value is 7. What could that number be? Well, the only thing it could be is this number could only be 7 or negative 7. I mean, there are only two numbers whose absolute value is 7. So the thing inside the absolute values has to equal 7 or it has to equal negative 7. So I ignore how complicated or the actual contents of the absolute value for this first step. The thing inside the absolute value has to be, in this case, 7 or negative 7. So I just set each of those equal to 7 and negative 7. And now I've got a non-absolute value equation that I can solve. Now I can just subtract 3 from both sides, divide by 2, subtract 3 from both sides, divide by 2, and there are the solutions to that absolute value equation. I've seen people get that rule wrong. Why did it say if b is bigger than or equal to 0? What if this had said absolute value of 4 minus x squared equals negative 5? Right. If I look carefully back at the rule on the previous page, the rule says only what to do if b is positive. What if b is negative? Well, think about it. This says they're telling me some number's absolute value is negative 5. What could that number be? Well, how many numbers have absolute value equal to negative 5? There aren't any such numbers like that. You take the absolute value of a number and you've got to get something positive. So there's no way that the absolute value of anything can equal negative 5. So I'm done. How about an inequality? Let's say, 3x minus 4 is in absolute value, it's less than or equal to 8. So here's how I think about this. I picture the number line in my head. And I forget about how complicated the thing inside the absolute value is. I'll just sort of blur that out for a second. That's a number whose absolute value is less than 8. Absolute value is distance from the origin. So this is a number whose distance from the origin is less than 8. Here's the origin. So this number is less than 8 units away from 0. That means it's less than 8 units to the right or 8 units to the left. It's got to be in here, including possibly the endpoints, because absolute value is less than or equal to 8. So what I know is that 3x minus 4 is in here. It's in this squiggly area. So rewrite that without absolute values. 3x minus 4 is less than or equal to 8, and also greater than or equal to negative 8. Whenever we write two inequalities in a row like this, we mean that they occur simultaneously. 3x minus 4 is bigger than or equal to negative 8 and less than or equal to positive 8. But now I can solve these two guys the same way I would solve a linear equation. How about I add 4 to both sides? Divide both sides by the positive number 3. That doesn't change the direction of the inequality. There. That's the solution to this inequality. It's all the x's between negative 4/3 and positive 4, including the endpoints. In interval notation, that's this, right? Let's try another. So I forget about that rule and I just think, this says the absolute value of some number is bigger than 8. Where on the number line could that number live? To have absolute value bigger than 8, you have to be farther than 8 units away from the origin. That means you're 8 units or more, you're more than 8 units away to the right, or you're more than 8 units away to the left. I need more of a number line. It's a good thing it's infinite. This 3x minus 2, to have absolute value bigger than 8, it's got to be farther than 8 units away from the origin. It's got to be in here, or it's got to be in here. Can't equal negative 8 or 8, because I'm not interested in numbers whose absolute value equals 8. So 3 minus 2x is in here, or it's in here. How do I write that with inequalities? Well, to be in here, 3 minus 2x is going to be less than negative 8, and there's no other way but to just use that word, or 3 minus 2x is going to be bigger than positive 8. But now I've got two non-absolute value inequalities that I can solve. So I'm going to subtract 3. Subtract 3. divide by -2, but be careful when you do, you have to flip the direction of the inequality. So when I divide by -2, I get x bigger than 11/2. Or divide by -2, x less than -5/2. And it always helps to draw a picture before you write down the interval notation. It doesn't have to be very accurate. It just has to help us figure out what to do next. X has to be in here, bigger than 11/2, or it has to be in here to the left of -5/2. So the solution set is, well, it's two intervals. This interval is from -infinity to -5/2, and I include a parenthesis or a bracket. Let's see, it's a parenthesis because I'm not including the endpoints. Right? This is x strictly less than -5/2. That or word is this symbol in mathematics. It looks like a capital U. It's read union. So this interval union this interval from 11/2 to infinity. And also I exclude the 11/2 because this is x strictly bigger than 11/2. Make sure when you answer questions like this on a test that it's very easy to read that that's a parenthesis and not a bracket. Why does the inequality rule say that b has to be bigger than 0? So let me try one more example. What if this said 3 minus 4x bigger than -5? So this says, I'm thinking of some number. I'm going to ignore how complicated that thing inside there is for a second. Its absolute value has to be bigger than -5. Well, if you think about it, absolute value is always bigger than -5. Because, in fact, it's always bigger than or equal to 0. So how many x's make this true? Every real number will make that true. The solution set is the whole real number line. We write it like this in interval notation. Right? No matter what number you put in here, 3 minus 4x has to have absolute value which is bigger than -5, because in fact it has to be bigger than or equal to 0. What about the other kind? I can squeeze one in here. 6. What if this had said 4 minus x squared has absolute value less than -2? So think about it. Ignore how complicated the thing inside the absolute value is. What kind of numbers have absolute value less than -2? There aren't any numbers that would satisfy that. I mean, everybody's absolute value is bigger than or equal to 0, so there's no x's that could cause this to be true. This has got no solutions. So I'd say the solution set is the set with nothing in it, the empty set. That's not a 0, it's a symbol. It's like a little circle with a line through it. It's a symbol that stands for the set that doesn't contain anything. It's used for precisely for problems like this, where we can write down some problem, but there are no x's that satisfy it. So the solution set is the set with nothing in it.